So we were talking about the different steps in permanent mold casting. The first one is that mold is preheated and coated for lubrication and heat dissipation. In the next step, cores, if any, are used, are inserted into mold and closed. So as you can see here, this is, let's say you want to create an internal surface, you should insert a core within your cavity, and this cord will be fixed to the body of the mold, so that when you pour your metal, it will fill the cavity, and that is determined by the shape here of your mold and the core. So once you make the setup, you put your core, you have your cavity, then you are ready to pour your metal. So the next step will be to pour your molten metal into your permanent mold casting system, and you will give it enough time to solidify. This will lead to formation of external surfaces through the cavity and internal surfaces determined by the core inserted. Now, after you are done, when solidification is done, you can open the mold and you can extract your final product. And since you didn't destroy your mold, you can repeat this process several times to have a mass production of the desired pattern. So, as expected, first, for permanent molding processes, you have first a good dimensional control and surface finish, because already your mold cavity is constituted by a metal instead of being constituted by sand, for example. You have rapid solidification caused by metal mold results in a finer grain structure, so casting is stronger. So as we said, because it's a metal used for the mold, you have a finer grain structure for it, and this will allow you to ensure the dimensional accuracy in addition to the rapid solidification because of the finer grain structure. Now, concerning limitations, generally it's limited to metals of lower melting point, because as we said, for larger melting points, you need to use a material that can sustain much higher temperature for your mold. Simpler part geometries compared to sand casting, because we need to open the molds, is another limitation. And also we have a high cost for initial preparation of the mold, but since we can use it several times, so if you have mass production, you can justify the use of this method. But if the number of products you want to have is limited, then there is no need to go to this type of permanent molding, because you need to invest a lot in order to fabricate your cast mold. Now, due to high mold cost, process is best suited to high volume production and can be automated accordingly. The typical parts are automotive pistons, pump bodies, and certain casting for aircraft and missiles. So these are the typical parts that are produced by this type of permanent molding. Now, the metals commonly cast are aluminum, magnesium, copper-based alloys, and cast irons. Some are not convenient to steel because of very high pouring temperature. So if you have metals to cast with much larger pouring temperature, you should do a specific treatment for your mold. Now, another type of permanent molding is die casting. A permanent mold casting process die casting is a permanent mold casting process in which the molten metal is injected into the mold cavity under high pressure. So here, one of the characteristic of die casting is the way of injecting the metal, and it's done under high pressure. So this is why pressure will be maintained during solidification, and then mold is opened and part is removed. Molds in this casting operation are called dies, hence the name of die casting. The use of high pressure will force the metal into die cavity is what distinguishes this form from other permanent mold processes. So relying on high pressure to introduce the mold in the cavity will be characteristic of this process here. Let us see, we'll see in some details how this system will work. So first, die casting is designed to hold and accurately close two mold halves and keep them closed while liquid metal is forced into the cavity. We can have two main types of die casting: hot chamber machine and cold chamber machine. In hot chamber die casting, the metal is melted in a container and the piston injects liquid metal under high pressure into the die. We can produce large rates of production up to 500 parts per hour. Applications limited to low melting point metals that do not chemically attack the plunger and other mechanical components. So one of the limitation here is that we need to use low melting point metals. The casting metals used in general in hot chamber die casting are zinc, tin, lead, and magnesium. So here we illustrate how hot chamber die casting is performed. So first, in the first step, you have with die closed and plunger withdrawn, so molten metal will flow into the chamber. So as you can see in the first step, we just fill the molten metal here into our chamber, okay? And then we will and then we subject our molten metal to large pressures, because due to large pressure, we'll be able to introduce the molten metal in this cavity, okay, where you can form very thin sections. So now, after you introduce the molten metal here, the next step is to apply pressure on it. So the plunger will force the metal in chamber to flow into die, which will maintain high pressure during the solidification, the cooling and solidification process. So as you can see, moving down this plunger will help you into forcing the metal to fill this cavity, and also you will maintain high pressure here. So the solidification will take place under large pressure, which will lead to enhanced mechanical properties of your final product. Once this process is done, the plunger is withdrawn and die is opened, which will allow to eject the final casting. Now, another type is of die casting is the cold chamber die casting machine. In this type, molten metal will be poured into unheated chamber from external melting container, and the piston will inject metal under high pressure into the die cavity. So we have some common things between cold and hot. Now, what are the main difference? You have high production, but not usually as fast as hot chamber machines because of pouring steps. Now, concerning the casting metals, we can use aluminum, brass, and magnesium alloys. And the advantages of hot chamber process favor its use on low melting point alloys. Let us see the different details of cold chamber die casting cycle. So with die closed and ram withdrawn, molten metal is poured into the chamber. And after this, the ram will force the metal flow into the die, maintaining pressure during cooling and solidification. So if you want, you have very similar steps, except that here you require to have the pouring step, while in hot chamber, you don't have to have the pouring step. So now, as the third step, ram is withdrawn, die is opened, and the part is ejected. Now, molds used for die casting are usually made of tool steel, mold steel, or maraging steel. Tungsten and molybdenum, which are characterized by good refractory qualities, are also used to die cast steel and cast iron. Ejector pins will be required to move part from die when it opens. So as you can see here, these are the ejector pins. And once we are done, we can, they are used to, if you want to remove our final product, and then they will be trimmed at the end. Now, lubricants must be sprayed onto cavity surface to prevent any sticking effect. So this is an example of a product that can be formed by die casting. You can see here a die casting that measures about 400 millimeter diagonally for a truck cab floor. So you can see that you can produce certain complex geometries using this system. And due to pressure effect, you can enhance the mechanical properties of such products. Now, concerning the advantages of die casting, it's economical for large production quantities. It ensures good accuracy and surface finish, and using it, you can produce thin sections. Furthermore, rapid cooling means a small grain size and good strength in casting. This is allowed by the pressure that is maintained during the solidification. Concerning disadvantages, generally it's limited to metals with low metal points, and part geometry must allow removal from die. So we have some geometrical constraint on the parts that can be produced. So we'll stop here and we'll continue next time. Thank you.